the UK's best plant-related investigative team. If you can afford them, maybe you could hire the Plant Squad.
Oh no, there's a dead plant.
Dr. Greenshield.
Oh, what time do you call this, Stonecroft? You've been here for ages.
Issues surrounding my timekeeping notwithstanding, Greenshield. What's the situation?
Well, we found an adult potato plant, was found dead, wilted. We're taking it away to the lab to see what's happening. But if I just found this, would you want to have a look with me? So here's a trail of bacteria. Let's see where it goes. Oh, look at that.
Fascinating. A species of bacteria that proclaims its innocence using its colony morphology. But it doesn't get us much further forward.
No, so let me collect some more samples and I will report back to you in the lab, maybe in about 1 hour or so.
Excellent. I'll look forward to it.
Good.
And Greenshield, you have half an hour.
Right, oh, okay. Stonecroft, where have you been?
Yes, sorry, Greenshield. I took a long lunch and then fell asleep in an allotment.
Right, I'm in the middle of something, but we're making progress. I've got 2 suspects and their MOs to tell you about.
All right, what have you got?
So the first one I thought about was nematodes.
Ah, plant parasitic nematodes. My ancient foe. And so it seems once more...
Before you go on, they're only infected roots and they're visible by the naked eye. We had samples looked at, we didn't see any, and this is the kind of symptoms you would see, and we didn't see any of that on our plant, so it's not them.
Of course.
The other one it could be is parasitic, plant pathogenic bacteria.
Ah, bacteria. Nature's most diminutive assassin. And so it seems once more I
But
shall be...
before we go on too much, that was the one that left evidence at the scene saying not me.
Of course.
But, you know, they may be lying. But also they cause these kind of chloritic lesions that die, this rotting. And also you sometimes get chlorotic spots. But what we found at the scene was very dead and these kind of fluffy leaves. So it's not that either.
So it's not nematodes and it's not plant pathogenic bacteria?
No.
What could it be?
Well, I need to run a few more samples, so say we have another meeting in an hour in the boardroom.
Very well, Greenshield. Excellent work. And by the way, you have 30 minutes.
No.
Ah, Greenshield.
What time do you call this?
Yeah, sorry about that. I briefly joined the circus. This is my sidekick, Bob.
Hi, Bob.
Hi, Greenshield.
Right, will we start our presentation?
Please.
I'll just recap, guys. This is one of the pictures from the crime scene. You see the sort of wilting symptoms, and this is associated with 4 suspects. We've already discussed nematodes, and we know that there's only really a wilting phenotype, but below ground you see this very striking root knots, and we didn't see any of them, so we ruled that one out. Right, guys? Okay, and next one is these fluorescent bacteria. We saw them at the crime scene, but these produce this kind of rotting lesions, and we didn't see any sign of them on our victim. So the next one we were thinking is plant viruses.
Ah, viruses. So once again it seems I must enter the dark castle of the virus, and there do battle...
But we know it's not that because we couldn't see any chlorotic symptoms, the spots that you associate with viruses, and there was no other leaf curling symptoms, so we know it's not viruses.
I see.
So our final suspect is something called omycetes.
Oomycetes?
Unusual structure causes fluffy leaves, and this is definitely what we saw at the crime scene. It grows, destroying the leaves, delivering effectors into plant cells, and goes down through leaves, causing rotting after a few days. So what we can conclude is we think this is a disease called potato leaf blight caused by Phytophthora infestans, so our suspect, we think, is omycetes.
Oomycetes then? Well, I don't know about you, Bob, but I think we've got enough evidence to make an arrest.
You already had me at Phytophthora.
Let's go.